Today we're going to be talking about this, the SIGLENT SDS1104X-U digital oscilloscope. Now in this video I'm going to give you an overview of this new model from SIGLENT, show you how it works, and then at the end of the video I'm going to give you my thoughts on what I think about it. Now just before I do that, I want to say if you find it interesting, please do consider hitting the subscribe button. I'm only able to keep making content by you guys supporting the channel, and subscribing is one way you can do that. Anyway, let's get on with this video and take a closer look at this new model from SIGLENT. Today we are taking a closer look at the new SIGLENT SDS1104X-U digital oscilloscope. This new budget model from SIGLENT features 4 channels and 100 MHz bandwidth. It's ideal for those looking to buy their first oscilloscope or upgrade on a budget to a 4-channel model. Whilst the SDS1104X-U is a budget model from SIGLENT, it certainly doesn't hold back on the features. It has everything you would expect from a modern scope, including multifunctional controls, measurement and decode features, history option, as well as many of the advanced controls for the trigger, the horizontal and the vertical adjustment as well. Popping around to the back, you will find yourself the power input, which is a standard 3-pin kettle connection, a fuse, as well as a Kensington lock port as well. You also have a LAN port, a USB Type B port for connecting externally, as well as the BNC trigger output. On the bottom, there are also 2 fold-out feet that allow you to actually tilt the scope up and back to make viewing the display a little bit easier. Taking a closer look at the spec, the SDS1104X-U features a 7-inch TFT display with a resolution of 800 by 480. It has a maximum bandwidth of 100 MHz and can support up to 100,000 waveforms a second. It features a 14 meg memory depth and can decode I2C, SPI, UART and CAN. It also has an FFT function up to 128K points as well. Now this new XU model features the latest SIGLENT SPO technology, and it has up to a 38 param auto measurement function. It supports video trigger including HDTV, and it has an up to 80K waveform history record as standard. Like previous models from SIGLENT that are similar, everything is laid out and nice and easy to find, including a soft power button, multifunctional buttons along the bottom of the display, the input selection next to the display, auto setup, your normal voltage and timescale settings, and trigger settings where you'd expect them. The display also shows a wide range of information, including the time base along the top, the frequency, the input and trigger options down the right hand side, as well as the mode options for the multifunctional controls along the bottom of the display too. Included in the box with this scope, you will find a user guide, a power cable USB cable, as well as 4 probes. Now these probes are the PP510's 100 MHz models. They feature a ×1 and ×10 switch as you would expect, and they have the small screw on the side for adjusting the capacitance. They include the small hook end as well as the usual probing end hiding below, and there's also a little bag with a number of accessories included too. They also feature a captive BNC which simply screws into the front of the scope, giving it protection as well. As I said, they also include a USB cable as well as a power cable, and you get a quick start guide as well as the certificate of calibration that gives you information when it should be calibrated next as well. The next thing we're going to do is take a closer look at some of the features and functionality of this SIGLENT scope. Now, I've got it hooked up to this old universal bridge. This is a very old piece of test equipment that I happen to have on the bench that I'm working on at the moment, and I thought I would use this just to display its onboard oscillator on the screen whilst we're looking at how some of the features on the scope work. Okay, so walking around the main functions and controls of the scope first of all. On the bottom left, we've got the power button, which turns the scope on and off. And then above this, we've got the menu on and off button that simply shows and hides the menu along the bottom. We then have 6 multifunctional buttons that control the options that are displayed on the menu. And these will change depending on what setting you're actually looking at the time. We then have a print button if you have a USB drive connected, our oscillator for setting our probe, as well as a USB port over here. So moving over to the right hand side, here's where we have the main control options. So we have these split into blocks. This area here is our main channel options as well as our vertical voltage adjustments. We have our horizontal time base adjustment as well as our trigger controls over here in this block. Here we have a multifunctional rotary control which allows us to select various options as we're going through the menus, and we'll take a look at that in a second. Along the top we have some of our smart features alongside our stop and run, our auto setup and default button, and then between the channels there are some additional functionality as well, including math, reference, roll, search, and we'll take a look at them a little bit more later on in the video. Looking at the channel options first of all, you can see at the top we're currently showing the frequency, which is the waveform we're showing on the display at 1 kHz. We've then got our current options, which is the memory depth, as well as how many samples we're taking a second. We then have our trigger functionality, which is showing we're picking up on the rising edge on DC on channel 1. And then below that, we have our channel options for channel 1, which is currently the probe setting, as well as the voltage increments on the display. Now, to turn each of the 1 to 4 channels on is simply press each button and the channel will turn on and show on the display. To turn them back off, you simply press the button again, and then the channel will turn off. Now, when you select each channel, this area up here will show the options for that specific channel. So for instance, we're showing highlighted channel 1 at the moment, and we're showing the settings, and this area is currently showing those vertical controls for that channel 1. If I turn on channel 2, you can see we're also picking up a voltage as well, and a signal is being shown. However, that is a different voltage compared to the top one, because if we look at the top one, it's on 500 millivolt increments, and the bottom one's on 50. So if I actually adjust the bottom one and set it, for instance, to 500 millivolt, you can see that it is a much smaller amplitude signal. If we wanted to change any of the other settings for channel 2, we could simply change them down here. So we could then change our coupling, so at DC, AC or ground, our bandwidth limit, whether it be full or 20 meg, our coarse or fine adjustment, our probe settings. So here we can set our probe, whether we want it on 1 times, 2 times, 5 or 10, and we can use this multifunctional controller up here to do that. And you can set all the way actually up to 10,000 or custom settings, but we're going to go back down to 1 because that's what we're using on that. Because channel 2 is selected, obviously adjusting the voltage reference only adjusts it for that channel, and I can actually adjust that one and put him down there. Press the top channel, and what we can actually do is reduce the voltage scale of the top channel and move him up to show both signals on the display. Now, these are actually signals off the same oscillator with just different voltages. The top one is a 3 volt signal and the bottom one is much lower. If you look, we're currently at 200 millivolt increments for the bottom one. So for instance, each box is currently representing 200 millivolts, and that is just under a 400 millivolt signal. Now, moving back to channel 1, we also here can set the time base if we want to via the horizontal control. Now, this will allow us to set the time base for the full signal. So as you see, we can go out or we can go right in if we wanted to take a closer look at the signal as well. And then the option below it allows us to set the time base position depending on what we're doing. Now, because the scope isn't actually stopped at the moment, it doesn't really change anything. However, if I set it back to center and stop the scope a minute and zoom in, it would now allow us to take a closer look at that signal and rotate along it and have a look if we can see anything that we wouldn't be expecting, some changes in the signal or anything like that. Or if I run the scope again, we can then zoom out and take the time base out further. Finally, over here on the right hand side is the trigger options, and here we have the setup for the trigger, which allows us along the bottom here to change things like the type, so edge, slope, pulse, etc., what channel the trigger is going to run off, whether it's off the rising, the falling or the alternating slope, hold off, the coupling type or noise rejection, and that is the main settings for the trigger. We then have the auto, normal or single fire modes. So normal, auto will automatically detect for you. Normal will just work and you would manually set the position of the trigger. So for instance, if I adjust it, and you can see the little trigger adjustment going up there. Or if we go to single, it will just fire every time I press the single button. And we're going to leave that back on auto. Now, above the trigger is your run, stop, auto setup and default button, as well as the clear sweep button next to the run and stop. Now, the auto setup is simply a quick way of getting the signal detected by the scope and displaying it on the screen. It should automatically detect what kind of signal it is and show it for you in the best possible way. Now, for instance, if I press default, it will reset all of the input settings back to standard, and you can see it's just showing channel 1 and nothing is being shown on the display. Now, we could manually go looking for this signal if we wanted to. For instance, it's currently 1 volt increments. If we wanted to, we could zoom right out and we can go, oh, there it is. There's the signal. It's appeared there. And then find the trigger and go adjust the voltage and go, oh, there we go, I found it. But what the auto option allows you to do is simply do it off one button press. So if I reset it back to default, hit auto setup, it'll simply search and it's displayed the signal for us on the display. So it's a nice, quick and easy way of just connecting up a signal, hitting the button and seeing if there's anything there. And it's more beneficial if you don't know if there's anything there at all, rather than looking for something specific. You then got the run and stop, which will simply run the display and then stop the acquisition of the scope. So now that it's stopped, if I zoom out, you can see that waveform has just stopped in the center. If I hit run again, it'll start acquiring, or I can zoom back out and it stops. And then you got the clear sweep button next to the run and stop, which will simply clear the display. And then if I hit run again, it'll run, or click stop, clear sweep. Or if I hit single, single would show it too. So if we zoom right back in, hit the clear sweep, and if I hit a single, it's taking a single snapshot, just like a snapshot on a camera when you're taking a still. Now the final things to walk over is the special functions, including the setting functions of the scope itself. Now you have the special functions showing with light up buttons, and then sort of the setting functions on the scope in hard buttons. So for instance, we've got our math options as well as our reference options. Now math is used for sort of, you know, adding or taking away from two signals. You can do addition, changing and differences, things like that. You've then got your reference options, a roll option, which changes the way the scope reads the signal and is simply rolling in from the right hand side of the display. We've got search, which allows us to search a part of a signal. We have our cursor options at the top, which allows us to adjust cursors on the display, adjust them individually, and you can set various options on this, like the axis type, X, Y, or both, manual mode, track mode, various other options like that. We have our measurement options that allow us to measure various parts of the signal, and this is one of the most important parts on a scope, because this allows you to actually get the information you need about the signal. So as you can see, if I just turn cursors off, you can see we've got some measurement options along the bottom, but we can actually bring up much more detailed options. For instance, if we click all measure, it'll bring up a big display of all of the main things you'd like to know about a signal, such as amplitude, frequency, duty cycle, and all of that's displayed there. Now, if we wanted to make it a bit easier to see, we would simply just move the signal down out of the way, or adjust the voltage reference for that. So we'll make the signal a bit smaller, put it at 1 volt increments and put it there so we can see it a bit easier. And as you can see, it's showing all of that. You can turn on statistics about the signal, so it will show them along the bottom, max, minimums on the options that you're searching here. Or we can then set up individual measurement options by pressing the type and simply find the one you want. So for instance, if we say, what should we turn on? Let's turn on maximum. Let's go along to maximum. And you can see maximum will appear over here, and that's obviously maximum off the 0, so it's 1.56, whereas the signal total is 3 volt peak to peak. And we can turn them on and off, and then you can change the channel source if you want to do things like that as well. You've got gate options, you've got statistics as I've shown, and then you've got the option to clear them as well, and they're all gone now from along the bottom too. And we can turn the measure on and off. We've then got our scope functionality options, which is display and utilities. So utilities shows us the main settings for the scope itself. So you've got system status, self-test, quick cal, sound on and off. You go to page 2, you've got pass fail, the I/O options for the LAN interface, the IP settings. You can go to page 3, the update, self-test, screensaver, and then a couple of other options there too. And then we've got the display options, which allow us to change things like the grid, the intensity, schedule, transparency, or whether we want vectors, persistence, or clear the display and set it back to the main settings. Now the last thing I'm going to show you is the history function, and this is actually quite a nice function within the scope, and this basically just stores some of the waveforms that you've been looking at recently in the history of the scope. To turn it on, you simply press the history button and the controls will come up along the bottom. If you press the list option, it'll allow you to select the signal that you want to look at. You can then hit play, and it'll allow you to play that signal back on the display. Now it is only a small capture of that waveform, but it is handy to be able to go back and look at things if you wanted to. You can then click navigate and you can change the navigation options, history frames or time, and we can then hit stop or turn the history function on and off. It's a nice feature to have. If you want to be able to store things though more permanently, you will need to plug in a USB device into the bottom of the scope and actually view it that way. Now that is the basic functionality of the scope covered. Now I have not touched too deeply on much of the more complex modes that this scope has, including the math, the decoding options, but it does have it all in there, and it is capable of doing things like decoding serial, I2C, UART, CAN bus. So it does allow you to do quite a lot of signal acquisition and signal analysis, as many other scopes on the market allow as well. Now, just before I finish this video up and give you my thoughts on this compared to a couple of the other models on the market, as well as my thoughts on it overall, I just wanted to mention two other things. The first is noise. This is not the quietest scope in the world. It has a cooling fan in it, and it is audible in a normal room when it's running. It's not really a problem, but it is something I wanted to mention. You can clearly hear it, and you'd know if you had it on in the corner of the room, for instance, and was walking away and had left it on. In this environment that I'm in, I'd certainly hear it. You can probably hear it over my mic now because I've got the lav mic on. If I lean in, you'll definitely hear it. It's definitely an audible fan sound. If you can hear a high-pitched whine, I'm not sure at this stage, don't worry, that's coming from that, but there is an audible fan noise from this model. The second thing I just wanted to mention was the boot time on this scope. It is not the fastest. In my tests, it's about 27 to 28 seconds. Whilst that isn't a major problem, the scope does seem a little bit slower overall at times, especially when you are zooming out to larger signals. When you're taking the time base right out, it does tend to lug a little bit, especially compared to some of the other models I've used. As a budget scope though, it's certainly not something I would class as a problem. So to give you my final thoughts on this new model from SIGLENT, well, the SDS1104X-U is directly based on the SDS1104X-E. However, this is a cheaper model. Both are 4 channels, and this one is available in 100 megs, as is that one. However, this one costs just $399 in the US, or about 430 to 450 pounds or euros over here. It is roughly $100 cheaper than the XE model, and SIGLENT have been able to actually make some changes to get the build of materials down to be able to put it out at the reduced cost. However, that means there are some things the XE model has that this one doesn't. Now, for the most part, 99% of people will not be able to tell the difference. The XE has dual ADCs, whereas this only has a single one. This one has reduced FFT memory, it has less RAM, and it has less capabilities on certain functions as a result of only having that single ADC. However, because it is in this budget scope category, most people won't be able to tell the difference. If you're someone who is looking to get a scope for the first time, or you're looking to upgrade your existing 2-channel scope to a budget 4-channel, this is probably the best one to go for compared to the XE model, because whilst you are getting a few different improvements for that extra $100, in my opinion, for most people, it isn't worth it. Now, this is another one in the many range of budget scopes that we're seeing come on the market right now. We are seeing them from all manufacturers, and the price of these is getting less and less all the time. For the money, there is a huge amount of features here, and there is a massive amount to like. In my use with this scope, I really can't find anything I don't like. About my only complaints on this scope would be the noise. It isn't really a problem, but it's certainly audible, and the slow boot time. But at the end of the day, I can wait 28 seconds for something to turn on for the most part. In the end though, for the cost, you are getting a hell of a lot for your money. Now, it is inevitable. It is going to be compared to other models from other manufacturers, including the 1054Z from Rigol. However, in my opinion, this is a better purchase. It has overall better specification, extra features, including extras on the decoding options and things like that. And whilst the Rigol is about $50 cheaper, I would spend that extra $50 and go for this model from SIGLENT compared to that one. If you're someone who is in the market for getting yourself a new budget scope, or you're looking to get your first scope, the SDS1104 from SIGLENT is well worth a look. I would go with the XU model and not the XE, and unless you have some specific reasons for getting those other changes, this is the one to go for. Now, If you're someone who understands a lot of the differences between the changes, I'll put a link in the description of this video to a blog post on the EEV blog, and there is also a really good review and teardown of this scope via Dave on the EEV blog. Here he goes into a lot more detail than I have. I've tried to steer a little bit away from going too technically deep on this one. I'd rather just cover it at a high level, because at this budget class, most people are just looking at what are the basic features, how does it work, and how easy is it to use. In the end, for $399, there is a hell of a lot to like here, and if you're getting a budget scope, you certainly won't go far wrong with this one. Now, that is it for this video. If you have found it interesting and useful, please do consider hitting the subscribe button. It is only by you guys subscribing to my videos am I able to keep making content like this. I'd like to say a big thank you to SIGLENT for sending this one over to me to have a look at. As I've said, it's well worth a look, and I would not hesitate for one moment in picking this one up to put on the bench. Finally, if you'd like to support the channel, there are some links in the description of the video. You can get this scope directly from SIGLENT, and there's a link to that in the description. You can also get it from Telonic Instruments in the UK as well. They are someone who's supported us in the past too, so please check them out as well. Finally, I do a live stream on a Friday night on this channel, and if you found this interesting, please check that out as well, where I also do a weekly drone news as well as electronic and other news, which will be carrying on in the future too. Anyway, that's it for this one. Thank you for watching, and I will give you guys some updates on some new products hopefully in the near future.